Hi, we meet again. Get ready. This is Statistics for Economics. Hello, how are you today? We meet again in Statistics for Economics, and in this session we are going to learn about the comparison of means. But before we talk about the comparison of means, first you should know the difference between descriptive statistics and inferential statistics. Well, descriptive statistics describe data, for example, a chart or graph, and inferential statistics allows you to make prediction or inferences from that data. With inferential statistics, you take data from samples and make generalizations about a population. For example, you might stand in a mall and ask a sample of 100 people if they like shopping at, let's say, Matahari. You could make a bar chart or yes or no answers that would be descriptive statistics. Or you could use your research and inferential statistics to reason that around 75 up to 80% of population, all shoppers in all malls, like shopping at Matahari. There are two main areas of inferential statistics: estimating parameters. This means taking a statistic from your sample data, for example the sample mean, and using it to say something about a population parameter, for example the population mean. The second one, hypothesis test. This is when you can use sample data to answer research questions. For example, you might be interested in knowing if a new cancer drug is effective enough, or if breakfast helps children perform better in school. Let's say you have some sample data about a potential new cancer drug. You could use descriptive statistics to describe your sample, including sample mean, sample standard deviation, making a bar chart or box plot, or describing the shape of the sample probability distribution. With inferential analysis, you can take the sample data from a small number of people and try to determine if the data can predict whether the drug will work for everyone or the population. Inferential statistics use statistical models to help you compare your sample data to other samples or to previous research. Most research uses statistical models called the generalized linear model and includes students' t-test, ANOVA, regression analysis, and various other models that result in straight line or linear probabilities and results. You can find hundreds of inferential statistics articles and hundreds of inferential statistic methods, but in this video, we only will talk about the comparison of means techniques. There are many cases in statistics where you'll want to compare means for two populations or samples. Which techniques you use depends on what type of data you have and how that data is grouped together. The four major ways of comparing means from data that is assumed to be normally distributed are: first, one sample t-test, independent sample t-test, paired sample t-test, and one-way analysis of variance or ANOVA. First, one sample t-test. Choose this when you want to compare means between one dataset and a specified constant, like the mean from a hypothetical normal distribution. 2. Independent t-test. Use this independent t-test when you want to compare means for two datasets that are independent from each other. 3. Paired sample t-test. Use this test if you have one group tested at two different times. In other words, you have two measurements on the same item, person, or thing. The groups are paired because there are intrinsic connection between them. For example, or of course they are not independent. This comparison of means is often used for groups of patients before treatment and after treatment, or for students tested before remediation and after remediation. And the last 4 is one-way analysis of variance or ANOVA. Although not really a test for comparison of means, ANOVA is the main option when you have more than 2 levels of independent variable. For example, if your independent variable was brand of coffee, your levels might be janji jiwa, say story, xie boba. Well, use this test when you have a group of individuals randomly split into smaller groups and completing different tasks, like drinking different choices. And if you have non-normal data, or if you don't know what distribution your data comes from, you cannot use any of before tests for comparison of means. You must use a non-parametric test. Non-parametric basically means that you don't know the distribution parameters. For independent samples, use the Mann-Whitney U test. This test is essentially the same as t-test for independent samples. For paired groups, use WILCOXON sign rank. This test compares medians, not means. Let's start it one by one. First, one sample t-test. The one sample t-test compares the mean of your sample data to a known value. For example, you might want to know how your sample mean compares to the population mean. You should run a one sample t-test when you don't know the population standard deviation or you have a small sample size. Assumptions of the test. Your data should meet these requirements for the test to be valid. First, the data has to be independent. Second, the data is collected randomly. And third, the data is approximately normally distributed. Okay, let's go to the example. Sample question. Your company wants to improve sales. Past sales data indicate that the average sale was $100 per transaction. After training your sales force, recent data of sales taken from a sample of 25 salesmen indicates an average sale of $130 with a standard deviation of $15. Did the training work? Test your hypothesis at a 5% alpha level. Well, let me tell you how to do this manually and using SPSS. Come. So here I would like to show you how to calculate or how to answer the question before using one sample t-test. So this is the question. Your company wants to improve sales. Past sales data indicate that the average sales was $100 per transaction. This $100 is called the population mean. So this is the population mean. After training your sales force, recent sales data taken from a sample of 25 salesmen indicates an average sales of $130. This $130 is called the sample mean. With a standard deviation of $15. The $15 here is the standard deviation, or the symbol is S. Okay, the symbol of population mean is mu, and the symbol for sample mean is X bar. Okay, so the question is, did the training work? Test your hypothesis at a 5% alpha level. So we would like to see whether this training is working or not by only using 25 samples. We want to make a conclusion for all the population of the salesmen. So the first step is write your null hypothesis statement. What is your hypothesis statement? The hypothesis null is there is no difference. There is no difference in cells before it means there is no difference in cells. And what is your hypothesis alternate? Your hypothesis alternate is there is difference in cells. For this one, we also can say that mu equals $100, and for this we say that mu this equal with $100. Okay, then number 3, identify the following pieces of information you'll need to calculate the test statistic. The question should give you this item: the sample mean. We have determined it before, the sample mean, and then the population mean, and then the standard deviation, and the number of observation. Oh, this is the number of observation, and the symbol of the number of observation is N. Okay, now the step 4. The step 4 is insert the items from above into the t-score formula. So I have prepared it for you. This is the t-score formula for one sample t-test. T equals x bar minus mu divided by s divided by the root of n. So put the information here to this formula, and we can say that T equal the x bar. The x bar is $130. minus the mu. The mu is $100 divided by the standard deviation 15 divided by the root of n, which is 25. Okay, and also we can continue it. $30 divided by 15 divided by the root of 25, of course 5. So 30 divided by 3 equals 10. So the t-score is 10. Now the step 5. The step 5 is find the t-table value. You need two values to find this, the alpha level and the degree of freedom. Where you can see the t-table value, you can use all of statistic books, because in every statistic book, in the end of the statistic book, they always give the tables like this one. The t tables is here in table 5. So open the table 5. Table 5. Okay. And as you can see here, first you have to find the alpha score. The alpha score is 5%. It means 0.05 here. And then the degree of freedom is n-1. The n is 25, n-1 means 24. So this is alpha 0.05 and the degree of freedom is 24. So you got the number 1.711. This is your table score. So I will write it down here. This is the t-score, this is the t-score, and this is the t-table, 1.711. So how to determine whether our hypothesis alternate is received or not? First, have to make like this one. Okay, if you have the hypothesis like this, it is called two-tailed. It means two-tailed. Here this is 0, here is minus 1.711, and here is 1.711. So if the range of your t-score is here, it means your hypothesis null is accepted. Hypothesis null is accepted. But if your t-score is out of this range, here or here, so your hypothesis null is rejected. In the other word, your hypothesis rejected. Your hypothesis alternate is accepted. And this t-score is 10. It means 10 is far away here, somewhere here. Let's say somewhere here, this is 10. So it means that your hypothesis null is rejected. Otherwise, your hypothesis alternate is accepted, which is there is difference in sales, or the sales is not equal as $100 for the all population, not only for the 25 salesmen, but for the all of population. It is not $100, but it is more than $100 because what? Because the t-score is in the right side, so it is more than $100. But if you make your hypothesis like this, hypothesis 1. There is difference in sales or the sales is more. The sales are more than $100. There is difference in sales. Sales are more than $100, or the mu bigger than $100. It is called this hypothesis contains one-tailed hypothesis. One-tailed. Sorry for my bad writing. One-tailed. Okay. So how to draw the curve? How to draw the curve? The curve will be like this one. Still same, but because this is more than, so we only use the right side, so only 1.711. So in the left side of this mark, in the left side of this line, the hypothesis null is accepted. The hypothesis null is accepted, but more than 1.711, the hypothesis null is rejected. It means your hypothesis alternate is accepted, which is there is difference in sales, and sales are more than $100, which is $130. We also have one other sample for one-tailed hypothesis. For example, you said that sales are less than $100, or we can say that mu less than $100. Mu here is the population mean. The population means are less than $100. This is also one-tailed, but one-tailed in the left side. So this is also one-tailed. So how to draw it? Let me show you how to draw it. Still the same curve, but the line, you have to use the left side, which is the negative one, the minus 1.711. So anywhere here means that a hypothesis null is accepted. But anywhere here, if your t-score is here, means that hypothesis null is rejected. And then you can see that your t-score is 10, and 10 is far away there. It means your hypothesis null is accepted, which is that the sales are not less than $100. So if it is one-tailed, the hypothesis null is not like this anymore. But if it is one-tailed, your hypothesis null will follow the hypothesis alternate. It means for this one, the hypothesis null is sales are no more than $100. And for this one, the hypothesis null is sales are no less than $100. So for this one, hypothesis null accepted, meaning that sales are no less than $100. Well, because the previous example doesn't have the data of each sales for that 25 salesman, then I will give you another example like this one. The production capacity of the old machine was 850 hours per machine. Then the firm A did an experiment for the new machine. When it performed 30 times, the data recorded as follows. This is the data of the experiment using the new machine for 30 times, and they calculated the endurance of this new machine 30 times. So the hypothesis null here is there is no difference between the old machine and the new ones, and the hypothesis alternate is there is difference between the old machine and the new one. Difference of what? Difference of the endurance, which is the old machine has 850 hours of endurance. So how to calculate this using the SPSS? First, you open your SPSS. It has two layers here. This is the data view and this is the variable view. First, you give the name of your column in the variable view. Give name hour. Enter. And you will got the type is numeric, the width is 8. You can make it less or more. The decimal is 2, blah 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 blah, unknown. It is a scale measurement. And back to the data view. After that, we should copy this into the data view. It is a little bit, okay, we cannot copy it, so we have to input it one by one, and it is really waste the time. So I suggest you to have a data from an Excel, because it will be save your time if your data is in Excel. Wait, so let's copy it one by one. Okay, I have transferred the data here in the data view. You can see the hours here. It is same as the end, which is 30. And what should do now? What should do now is we open the analyze and then compare means. Then we choose one sample to test, and we enter the data to the test variable. This is hours, and then the test value here we enter the capacity or the endurance of the old machine, which is 850. After that, we click the OK. Okay, let's see the output. Well, here is the output. Let's see that the mean of that data that contains of 30 experiments is 816. So from the mean, we know that the mean is not as exactly same as the old machine, which is 850, but it is still the sample. How about to conclude whether the new machine is same as the old ones or not? Let's see the table below this one. So you can see the significance here is 0.001. okay, it means that if the significance is less than 0.05, it means the hypothesis alternate is accepted, which is there is difference of the endurance between the between the old machine with the new ones, and so they are not same. The new machine is not same with the old one. As you can see that the new machine has the less endurance than the old one. So you can see from here the significance is less than 0.05. It means the hypothesis null is rejected and the hypothesis alternate is accepted. If you want to confirm it one more time, you can see the t-score here. This is the t-score, and you can compare this t-score with the t-table that you have known in the manual calculation before. In the manual calculation, you got the you got the the t-table is 0.711, and in this one the t-table is 3.661. It is way less than negative 1.711. It means that the hypothesis null rejected. So there is difference between the endurance of old machine and the new one.